Hello guys, welcome to our math lesson. Now today we are going to be looking at fractions that are greater than 1. Now as always, we've got our starter questions. Have a go at these. So pause the video and see if you can get the right answers. Okay, so question 1. Well, 24 divided by 4. What I need to do is count up in my 4s to see how many gets 24, and that is 6. Next, number 2, how many tenths are there in one whole? Remember, so in my tenths, how many does it take to get to one whole? 10 tenths are in one whole. How many tenths are in 2? 20. And then next, how many hundredths, so the key here is hundredths, are there in 5 wholes? Well, hundredths, tenths, in 1 tenth there are 10 tenths in a whole, so in 5 hundredths there must be 500. Okay then, so let's have a look at some fractions that are greater than 1, how we represent them. So here I have got my shape, and I am split up into sevenths, and all of it is shaded in, so that is 7 sevenths. Underneath, I've got the same shape, but I've only got 2 shaded in, so I've got 2 sevenths. If I wanted to represent this as a whole, what I would need to do is I would need to count up how many shaded up I've got, so I've got 7 sevenths. Add 2 sevenths, so I would have 9 sevenths altogether. Can you notice that the denominator is not changing in this? The only thing changing is the numerator. So I've got 9 sevenths. Next, I have got sevenths again. So I've got 7 sevenths equals 1 whole. And then 2 sevenths, add these together, 9 sevenths altogether. 9 sevenths equals 1 whole and 2 sevenths. You can see here I've got my 1 whole and 2 sevenths. Next, I've got sixths, but only 2 of these are shaded in, so I've got 2 sixths. And then underneath I've got my sixths again, because I can see it is the exact same shape split into sixths, and I've got 5 shaded in, so that would be 5 sixths. Again, if I want to add these up together, I would need to do 5, add 2, because my denominator doesn't change, does it? 5 add 2, I know that that is 7 sixths altogether. So there are 7 sixths altogether, nice and clear. If an easy way, I could go 1, 2, 3, 4, 5, 6, 7, or I could just notice that 2, add 5 equals 7. Remember, my sixths stay always the same, my denominator. Another way I could move this along to make it easier for myself, just to really see that I've got 7 sixths. So I've got 1 whole altogether, and then 1 sixth, which equals 7 sixths. So now there are 2 questions on the screen now. Can you rewrite these sentences into your books and fill in the gaps? So remember, your denominators do not change. So here I can tell that we've got fifths as our denominator, and here we have got halves. Can you count up how many you've got altogether? How many have you got? Then see how many wholes and how many fifths. Pause the video and give this a go. Okay then. So there are, well, let's see, so we've got 5, we've got 3, which is 8, and then we've got another 3, which is 11. We've got 11 shades in altogether, so therefore I've got 11 fifths altogether. So therefore 11 fifths, well, if I'm counting up in my fact, I know that 5 fifths is 1 whole, and I've got 11, so if I count up 5, 10, I've got 2 wholes, and then I've got 1 left over because I need to get to 11, so 1 fifth is left. So 11 fifths equals 2 wholes and 1 fifth. Next, well, there are 1, 2, 3 halves altogether. So therefore 3 halves equal, I can see I've got 1 whole, or again, if I wanted to count up, I know that it's 3 over 2. Only 1 2 goes into 3, and then I've got 1 left over. So 1 whole and 1 half. Now guys, pause the video and have a go at questions 1 to 2 on the worksheet. Okay, then let's continue. So here I've got 12 sixths, and we call this an improper fraction. And all an improper fraction means is that our numerator is greater than our denominator. So in this example, we have got 12 sixths. So if I was going to show this represented, I've got my sixths because that is my denominator. I split my shape up into 6, and I've shaded it fully in, which is 6 sixths. And I've got my other shape split into 6 again with 6 sixths. So if I add these two up, I've got 6 sixths, add 6 sixths. Remember, my denominator stays the exact same, and I just add my numerators together, and that would equal 12 sixths. Or I could say it equals 2 wholes. My next shapes, on my next fraction, I've got 18 sixths. So in my shape again, I'm splitting this up into sixths, and I'm shading it all in. I've got 6 sixths. Again, I've got 6 sixths. And again, I've got 6 sixths. So if I add these up, I've got 6, add 6, add 6, which is 18. And remember, my denominator does not change. Another way that I might be able to work this out, I know that I've got 6s. I could say how many 6s go into 18? Well, I could count with my 6s. I got 6, 12, 18. So I know that there are 3 wholes. Well, there are 18 6s. So just here, this is showing again, I've got 6s. So how many 6s go into 18? Well, 6 times 3 equals 18. Or another way I might want to work it out, I could do how many 18 divided by something goes into 6. Well, I know 18 divided by 3 is 6. So therefore, it is 3 wholes. Because 18 is 3 times greater than 6. So my next improper fraction, I've got 20 fifths. So I'm going to show this as part of my modelling. So I've got 1 whole, 2 wholes, 3 wholes, 4 wholes. Or an easy way I could work it out. So I've got fifths. How many 5s go into 20? Well, if I cancel my 5s, 5, 10, 15, 20, I've got 4 wholes. Or if I wanted to just count, well, I've got 5, 10, 15, 20, and I've got 20 in my numerator, but my denominator does not change. 25ths, again, another way, 5 times 4 equals 20, 20 divided by 4 equals 5. Now this time, it's not going to be as easy. So now I've got 10 sixths. So how many 6s go into 10? Well, it's not as easy as they were last time. So let's show this represented. So I've got my my bar model split up into 6 equal parts. I'm going to shade in 6. And I'm going to have another one, but this time I am only going to add on 4 more because that would equal 10 sixths. So I've got 6, add 4 equals 10. So I've got 1 whole and 4 sixths. A way that I might want to work this out without doing my representation, I could do 1 whole, which is, I know 6 are how many 6s go into 10. Well, 1 6 goes into 10, and then I've got 4 left over. So it's 1 whole and 4 sixths. So now guys, in your exercise books, can you write out these problems with our sentences? So now guys, in your exercise books, can you copy down these sentences with our fractions, and can you fill in the blanks? So you might be able to do this the way that I showed you. So looking at our denominator, so 3 goes into 11 how many times, and then how many are left over is how many thirds we've got. Or you might find it easier to draw your shapes, split them into thirds, and then how many shapes have you got, and then how many are left over. Give them a go, guys, and then come back to me and we can see whether you've got them right. Okay then. So 11 thirds. Well, I know that 3 goes into 11. So it goes in 3 times, because it doesn't go in 4 times, because 3 times 4 is 12, and that's too much. I cannot go over. So 3 times 3 is 9. So I've got 3 wholes, And then, so 9, 10, 11, I've got 2 left over, so that means I've got 2/3. Next, 9 halves. So 2 multiplied by something, what's the closest number that I can get to 9? Well, I can get to 8. So 2 times 4 equals 8, so I've got 4 wholes. And then 8 plus 1 equals 9, so I've got 1 left over. So I've got 4 wholes and 1 half. And then finally, 20/7. How many wholes am I going to have? Well, 7 multiplied by something equals, well, 7 multiplied by 2 is 14, because 7 multiplied by 3 would be 21, and that is over my my numerator. So 7 times 2 is 14, and then I've got 6 left over. So 2 wholes and 6/7. So now, guys, we're going to have a look at comparing our two fractions, our improper fractions. Which one is going to be bigger? So we're going to use my greater than, less than, or equal to signs in here. So let's represent these fractions to see which shapes are bigger. So I've got 7 halves. So I'm going to draw, well, I know 1 whole, 2 wholes, 3 wholes, and a half. I could do this in my head. So 2 goes into 7, well, it goes in 3 times with 1 half. So now I'm going to represent 7/5. Well, I know that 5 goes into 7, goes in once, and then I've got 2/5. So I can see here I've got 3.5 or 1 2/5. So I know that 3.5 is much bigger because I've got an extra 1 whole there and then some. So I know that this side is bigger, so 7.5 is greater than 7/5. Let's have a look at the next one. So 24/6, and I've got 16 quarters. Well, 6 goes into 24, well I know that it goes in 4 times. And then 4 goes into 16, well I know that 4 times 4 is 16, so it goes in 4 times again. So on both sides, I have got 4 wholes, so therefore it is equal to. So now you've got 3 questions again, or in fact you've even got 4 questions. Can you have a go at working out what each of these improper fractions are and which way that is it going to be greater than, is it going to be less than, or is it going to be equal to? Write this out into your exercise books, pause the video and have a think. Okay then. So firstly, 2 wholes and 3/5. So I'm doing it in fifths. So I've got 2 wholes, therefore it's going to be 10, and then 13/5, and then 9/5. Well, that 13/5 is greater than 9/5. Next, 28/7. Well, I know that 7 goes into 28 4 times, so I've got 4 wholes, and then 12/3, well, 3 goes into 12 4 times, so this is actually going to be equal to. Next, with number 3, 6 goes into 9 just once, so I've got 1 whole and 3/6. Then 17/8, well 8 goes into 17 twice, and then with 1/8 left over, so I've got 2 wholes on this one, so 17/8 is greater than 9/6. And then finally, 20/10, that's 2 wholes, but now I've got 20/9, so I've got 2 wholes and 2/9, so 20/9 is actually greater than 20/10. Now guys, it's your turn to have a go at the worksheet. Pause the video and have a go at questions 3 to 6, and then come back to me once you've finished. Okay then, so now we've got 11/6, and we all know that this is an improper fraction. So if I'm going to represent this, I've got 1 whole, 6/6, and then I've got 5/6. Because 6 goes into 11, it goes in once, and I've got 5 left over. But another way that I can represent this is by using a mixed number fraction. Now to show this, all I need to do is, so I've got 6/6, which is 1 whole, so I put a big 1, and then next to it, if my numerator isn't quite 1 whole, so I've got 5/6, I can then put that next to it, so it's 1 whole and 5/6. Just another way of representing an improper fraction. So I've always got to make sure my numerator is less than my denominator when I'm doing this. So if for example, if this was then 6 sixths, I would not have any 6, I would have the number 2 there because I'll have 2 wholes, wouldn't I? Another example of this is 7 sixths. So well, straight away I know that I've got 1 whole because 6 goes into 7 once, and I've got 1/6 left over. But to show this, again, I've got an improper fraction. I've got 6 sixths, and I've got 1/6. So as a mixed number fraction, I've got 1 whole, and I've got 1/6. So now, if you've got this far, there is now a worksheet, and it's all about chocolate. I want you on that to give it a go. It is about mixed number fractions and improper fractions, so give it a go. Make sure that you take a picture and upload to Teams, and I'll see you in the next one.